Hi, I'm Adithya, Vasanth, and this is me flying my first plane. Ever since I was a kid, planes have always fascinated me, but being up there looking over the nose of a Cessna gave me a totally new perspective. While I was up there scanning the horizon for other aircraft, I saw a bird zip by, and it hit me. We are flying right through their home. I knew how I was scanning through the sky, but it made me wonder, how exactly do birds see my plane? It turns out, understanding comes down to vision science. We assume birds can easily spot a massive metal object and just get out of the way, but their eyes aren't built like ours. Humans have forward-facing eyes, giving us great depth perception. But many birds, like pigeons, starlings, and sparrows, have eyes on the sides of their heads. This gives them amazing panoramic vision to watch for predators, but limits how well they can judge distance directly ahead. To get a better read on what's in front of them, they often have to tilt or bob their heads, rather than simply look straight forward. Not all birds are like this, though. Owls, hawks, and eagles actually have forward-facing eyes much like ours. But the species most commonly involved in bird strikes tend toward the lateral eye design, which is why this matters for aviation safety. On top of that, birds process light differently. They have a much higher flicker fusion rate than we do. To a human pilot, an aircraft's strobe lights may look like bright attention-grabbing flashes, but to a bird's hyperfast vision, those same lights might look like a slow, dim flicker that is easy to miss in a bright sky. Plus, birds have tetrachromatic vision, meaning they can see ultraviolet light, a whole spectrum of color completely invisible to the human eye. So for many species near airports, we're flying fast machines with warning systems that weren't designed for how they see. But here's the cool part. If we understand how birds see, we can fly smarter and prevent dangerous bird strikes. Oregon-based Precise Flight developed their FAA-certified pulse light system, now installed in over 25,000 aircraft, which pulses exterior lights at a rate better suited to avian vision, giving birds more time to react. Illuminator Aerospace has taken it even further, developing LED lights specifically tuned to the broad spectrum of avian vision. Meanwhile, researchers at the FAA's Williams J. Hughes Technical Center have been testing pulsing ultraviolet LEDs on aircraft, invisible to humans but potentially far more conspicuous to birds. So in conclusion, the future of aviation isn't just about building faster planes. It's about understanding the biological science that makes flying safe and sustainable for us, for the wildlife, and for future generations of pilots. By learning how birds see the sky, we're not just preventing accidents on the runway, we're gaining the insight to protect the skies we love. Thank you for listening.